In statistics, choosing the correct diagram is just as important as performing the correct analysis, because using the wrong diagram can lead to misinterpretation. Today, we will learn how to choose the appropriate diagram based on the type of data. Remember, the type of diagram depends on the type of data. If you haven't watched my previous video on types of data, you can find the link in the description below. Let us first look at qualitative data. When you are presenting frequencies or counts, and when there are many categories, a bar diagram is the best choice. It provides better clarity and makes comparison easier. For discrete data, where values are distinct, such as 0, 1, 2, or 3, we also use a bar diagram. For example, the number of students in different classes, or the number of products sold by salespersons in a day. Now, let's look at pie charts. When there are many categories, a bar diagram is more suitable because it makes comparison easier. But when the number of categories is small, like 2 or 3, a pie chart is more effective. A pie chart is especially useful when we want to show how each category contributes to the whole. For example, monthly income divided into food, rent, travel, and savings. Blood group distribution among patients. Out of 100 patients, 30 have blood group O, 25 have blood group A, 20 have blood group B, and 25 have blood group AB. Now, subdivided bar diagram, also called a component bar diagram. When we want to compare categories and also see the internal composition within each group, we use a component bar diagram. For example, male and female admissions across different batches, or number of patients in different years classified as new cases and old cases. Next, a compound bar diagram, also called a multiple bar diagram. This is used to compare two or more related variables for the same categories. Here, bars are placed side by side for each category, and each bar represents a different group. Example, number of male and female patients in different departments. Comparison of normal delivery and C-section cases in different hospitals. If the total number in each group is different, converting the data into percentages makes comparison easier. In such cases, a percentage bar diagram is useful. If the total number in each group is different, a percentage bar diagram becomes very useful because it helps us compare proportions instead of absolute numbers. For example, consider two branches of a retail store. In branch A, there are 500 customers in a day. Out of them, 250 purchased groceries, 150 purchased clothing, and 100 purchased electronics. In branch B, there are 200 customers in a day. Out of them, 60 purchased groceries, 100 purchased clothing, and 40 purchased electronics. If we look only at the numbers, branch A seems to have higher sales in every category. However, this is because it has more customers overall. When we convert these into percentages, in branch A, groceries account for 50%, clothing 30%, and electronics 20%. In branch B, groceries account for 30%, clothing 50%, and electronics 20%. Now, using a percentage bar diagram, we can clearly compare the proportions. We see that groceries dominate in branch A, while clothing dominates in branch B, even though the total number of customers is smaller. This shows how percentage bar diagrams help managers make better decisions by comparing relative performance rather than absolute numbers. Next, scatter diagram. A scatter diagram is used to study the relationship between two numerical variables. Each point represents one observation. If the points move upward, it shows a positive relationship. For example, as body mass index increases, blood pressure may increase. If the points move downward, it shows a negative relationship. For example, as physical activity increases, blood sugar levels may decrease. If the points are scattered randomly, it indicates no relationship. So, a scatter diagram helps us understand the direction and pattern of association. Next, a line graph. A line graph is used to show how a variable changes over time. It helps us observe trends and patterns. For example, daily electricity consumption, patient blood pressure over several days, blood sugar levels over time, and heart rate monitoring. Whenever we study changes over time, a line graph is the best choice. Next, histogram. A histogram is a graphical representation used to display the distribution of continuous data. In a histogram, data is grouped into class intervals, and the height of each bar represents the frequency of observations in that interval. For example, consider the ages of patients grouped as 0 to 10, 10 to 20, 20 to 30, and so on. Each interval is shown as a bar, and the height of the bar shows how many patients fall into that age group. Unlike a bar diagram, there are no gaps between the bars in a histogram because the data is continuous. A histogram helps us understand the shape of the data, whether it is symmetric, skewed, or has any peaks. So a histogram is very useful for visualizing how data is distributed. Now, let's look at the box plot, also called a box and whisker plot. A box plot is used to show the distribution and variability of numerical data. It summarizes data using 5 key statistics: minimum, first quartile, median, third quartile, and maximum. It helps us understand how data is spread. For example, if we have the marks of students, it can show the median mark, the spread of marks, and the lowest and highest marks. So instead of looking at each number individually, a box plot gives us a clear picture of how the marks are distributed. It can also use to compare different groups. For example, blood pressure between males and females, blood sugar before and after treatment, cholesterol levels in different treatment groups. It is also useful for identifying variability and detecting extreme values or outliers. Finally, let's understand maps. A map is used when data is related to geographical areas, such as states, districts, or countries. It helps us understand how a variable changes from place to place. For example, distribution of malaria cases across districts, COVID-19 cases across states, or prevalence of anemia in different regions. On the other hand, a diagram is used to present numerical data in a simple visual form, such as bar charts, pie charts, line graphs, or map diagram. It helps in comparison and understanding trends, and for location-based data, choosing the correct diagram is very important because it helps present data clearly and avoids misinterpretation. If you found this useful, don't forget to like, share, and subscribe to the channel for more statistics made simple. Thank you, and see you in the next video.